Hello, in this video, we will continue the discussion of reaction of aldehyde and ketone as part 4, and specifically we will try to discuss about the formation of acetal and how can we use this acetal in different reactions. That is the part that we will try to discuss. So let's review quickly about the acetal formation. What we said in our part 3 is when we react aldehyde or ketone again uh, with the diol containing two OH group on the same molecule. Let's say this is like a 1,2 ethane diol. If we react with ethane diol, 1,2 ethane diol, in presence of acidic condition, in presence of a little bit of acid, then it will form the cyclic acetal R prime, and here is O and O, two OR group, but both OR group will be on the same molecule. So that is how you will form this like cap like structure. This is what we call cyclic acetal. It will result in the formation of cyclic acetal. And we mentioned that this cyclic acetal has very important synthetic application. The reason is that we can remove this cyclic acetal very easily by doing the acid hydrolysis, right? Uh, H2O in presence of acid hydrolysis, then it will give you back your aldehyde or ketone depending upon whatever you use that, so you will get it back. So that is how you can get the aldehyde and ketone back from the cyclic acetal. So because of this reaction, we can use the cyclic acetal as the protecting group for aldehyde and ketone. Protecting group for aldehyde and ketone. Now let us try to see one very important application for this process. Their application. Okay. Let us suppose you have this is one problem in your assignments. So this is the aldehyde and other side you have bromine. Now we wanted to modify this group with the bromine in there. We wanted to do the Grignard reactions and varieties of other reaction at this bromine part. But the problem here is this aldehyde group being very reactive. Therefore, now if we don't want it to touch this aldehyde group, we don't want it to modify this aldehyde group, and we wanted to do the reaction only on bromine, then what we need to do is we need to protect this aldehyde group. That is when we will form the acetal. Once you protect this aldehyde group by making acetal, you can do whatever reaction you want on this bromine, like a formation of the Grignard reagent and then reacting with the aldehyde and ketone and other varieties of other reactions that we can do with the Grignard reagent. And finally, you can get this aldehyde group back by doing the acid hydrolysis. Now let us see the series of reactions that we carry on here. Say for example, first reaction that we will do here is the protection of aldehyde group there. So that the reaction is with ethane diol. Okay, and this reaction takes place in presence of little bit of acid, that is H plus, which you can use that as the dilute sulfuric acid. That is the first reaction. So this is the first step. Second step, that will allow you to protect this. Second step, say you wanted to do the Grignard reaction with the halogen, magnesium in presence of ether. Once you make the Grignard reaction, the third reaction you wanted to do with the Grignard is then react with something like aldehyde. This I will copy the problem from your assignments. So it's like PHCHO. That is, this is the you are reacting the Grignard with the aldehyde, and ultimately you needed to do the deprotection of this uh, cyclic acetal. So for that you need the acid hydrolysis. So you will do little bit of acid, which can be HCl, right? You can write HCl and H2O also, or H plus and H2O. So this is, and now here is, so what is the final product on this series of this reaction? Okay, this is the type of the question you should able to um, able to work in the course of this study. So again, so at this point, what you need to understand is, well, this is the ethanediol. By the way, this ethanediol you can write like this: CS2, CS2OH, and OH is the same thing. This is same as you write this. This and this is same thing. Remember your condensed formula and the line angle formula. Either you write this way or this way is same, and you are doing this reaction in presence of acid. You can put just H plus, or you can put H2SO4 dilute sulfuric acid. So that is the first step. So let us go step by step of this reaction. So first of all, bromine, we have aldehyde, and you are doing the reaction with ethanediol in presence of H plus, or you can put again sulfuric acid. So what is the result here? The result is that will protect this aldehyde group. So you this bromine as it is, and here this is how you draw. Okay, and when there is C double bond O, that will make a cap like structure like this. This is what we call the acetal, cyclic acetal. Let's say that way, cyclic acetal. Now once you form the cyclic acetal, so this is step one. Step one, reaction with step one. So this is the one that we did. Now the second step is, then you are doing the reaction with magnesium and ether. By the way, this is the reaction of magnesium with, sometimes we write ether. By the way, the with ether, it will be given like this also. It is same thing. Remember, either we write this way, Et2O, or simply ether. Full word ether is the same thing. Okay, this is same thing. So be aware about that. So what does it do? When you see magnesium and the bromine, then its job is to make the Grignard reagent. It is Mg and Br. You insert the magnesium in between. Okay, so that is when you have O and you are O and you have hydrogen there. So this is now Grignard reagent. And in Grignard reagent, you know that this carbon will be slightly negative and magnesium will be slightly positive. This Grignard reagent then react with there is a PHCHO, that is actually aldehyde, is the reaction with aldehyde. So you see in the third step, that is reaction with PHCHO. CHO is aldehyde. And now you know how the negatively charged carbon on the Grignard reagent react with aldehyde. We have studied that previously. This will attack on carbonyl carbon, and O will go as O minus. Now here again, the main challenge here is how to write the product. So again, my best advice is copy all the other thing as it is. So you have your hydrogen and you have your cyclic acetal, okay, and this is the other carbon. That carbon now is connected with the carbon which has got pH, which has got hydrogen. It will be O minus, and this is where this MgBr, so you have MgBr, that is a positive part, that will go and attach with negatively charged oxygen. So OMgBr will be plus. So this is the result from this. Again, this carbon is connected with this carbon. You will just form the bond. Okay. And MgBr is going and attach to the O negative. Now with this, so you will not isolate this kind of product. So MgBr now you can convert into H. So you will do just hydrolysis, H2O and H plus. So you have carbon, hydrogen. This is your pH. So now this becomes your what? OH with hydrolysis. And this is other carbon, uh, other carbon here. So this is carbon, and you have 1 2 carbon, and this is when you have your O, and this is your H. Okay, this 1 2 carbon, 1 2 carbon. Okay, yes, so this is the result. And ultimately, the last step is you wanted to deprotect this cyclic acetal. So that is when HCl and H plus H2O, or H plus and H2O acid hydrolysis will remove this cyclic group. So the result here is carbon you have, there is hydrogen, let's write it a little bit properly, and you have your OH, this is connected, and this is where you have your double bond O and hydrogen. This is your final product. So this is how you can predict the product, ultimate product, by following the sequential reaction, and this is the application of cyclic acetal. It's a very popular reaction that we need to be aware about this in your uh, part. Now the last other final reactions of aldehyde and ketones are, you all aware about the oxidation reaction, and we know that aldehyde, okay, aldehyde, if you use the oxidizing agent, like oxidizing agent, okay, like sodium dichromate, potassium dichromate, okay, potassium permanganate, that will go to carboxylic acid. Aldehyde will oxidize to, so RC double bond OH with any kind of oxidizing agent will go to carboxylic acid. We have been talking about that from chapter 11 also. And ketone will not oxidize, so no oxidation without breaking the bond. Okay, without breaking the bond, there is no oxidation to that. And the last reaction is about the reduction of aldehyde and ketone. This reduction is about the two reagents that we normally use. Say if you use aldehyde or ketone, say for example this type, if H is aldehyde, and if you use R prime as the ketone, you can use sodium borohydride, which is a mild oxidizing agent, and will mild reducing agent, reducing agent will convert aldehyde into primary alcohol. So the double bond will remain intact, and then this aldehyde will convert into CH2OH. So this is your primary alcohol. Uh, and if we have a ketone, then that will, so primary alcohol, and if it is a ketone, that will go to the secondary alcohol, obviously. So you have OH and here R prime. So this is your secondary alcohol, depending upon whether it is aldehyde or ketone. And we can reduce that by using a strong reducing agent, lithium aluminum hydride also. The result is again the same. If you have, so the double bond will remain untouched. Okay, so this will go to OH, it may be H or R prime depending upon aldehyde or ketone. But however, if you use the reducing agent like ranitidine, so hydrogen in presence of nickel, okay, ranitidine, then it will reduce the double bond also, and aldehyde and ketone also. So it will convert into the single bond, and this will go to OH, H, and it can be H or R. So that is how the reduction reaction takes place. Yeah. So the last one that we need to discuss about the aldehyde and ketone is about the what we call the deoxygenation reaction. That is basically, so if you have aldehyde or ketone, H or R prime, then you can easily use what we call is a Clevenson reduction, that with zinc and HCl